Hello, my name is Samuel Scrivens. I'm going to be doing a presentation on GPR, ground penetrating radar. So ground penetrating radar was created by Walter Stern in 1929. He was very interested by the phenomena of electromagnetic waves traveling, and he decided to create GPR in order to study the depth of glaciers. So the principles behind GPR is an electromagnetic wave is transmitted through a medium. And when this happens, there's a material property called permittivity. And permittivity, as an electromagnetic wave travels through a medium, if the permittivity changes, the wave becomes polarized and reflects some of the energy back to the surface. Now, this energy that returns can be measured at a receiver, and the time taken between transmission and reception will denote how deep the change in permittivity is. So there are certain things that affect an electromagnetic wave. So the magnetic permeability, which is the amount of electromagnetism inside the material, the conductivity, how well electrons travel inside the material, the frequency of the transmitted wave, all have an effect called attenuation on the wave. So attenuation decreases the power of the wave as it travels through the material. Higher the frequency, the higher the conductivity, the higher magnetic permeability. All this means that the wave will attenuate faster. So that means that low frequencies are preferred in terms of radio waves. So in terms of the actual hardware, it's created by a frequency modulator, which takes an input signal and steps either up or down the frequency by some multiple. So you can achieve, let's say, a bandwidth of frequencies that you wish to fire through the transmitter with this frequency modulator. It travels to the transmitting antenna. The antenna does something called polarization, and it sends the electromagnetic wave through the surface, through the medium, and it returns as the permittivity changes. That means at each point it reflects. And so you can see that the depth, you can see a varying amount of depth as the wave reflects and comes back. It's received, it's demodulated, which means that the information is taken from the carrier frequency, and then it's sent to signal processing to further uncover the data. Now, frequency determines the resolution at which is best for GPR analysis. So if it's higher frequency, it'll penetrate less, but the resolution at a lower penetration will be better. Now, at more depth, it'll be less. So that means if you want depth, you need a low frequency, and that provides a high resolution at high depth. So unfortunately, I wasn't able to produce a physical form of the GPR due to many circumstances outside my control. But that's it. Thank you.